Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is for the second part for chapter random variable. So now we will be looking at cumulative distribution function. Okay, so this cumulative distribution function is just about the same thing with cumulative frequency. Okay, that thing is called as cumulative distribution function. That is denoted with the symbol of ft, for example. Okay, so this ft is equal to the probability of x that is less or equal than t, and also equal to the summation of t x1 probability of x equal to x. Okay, so we focus on this part only. Okay. Right. Okay, for cumulative frequency, for example, we have a data of cumulative frequency of, okay, so this is the x, this is the frequency. For example, our x is 10, 20, 30 and 40. Our frequency is then 1, 1, 2 and 3. Then the way we calculate cumulative frequency is by adding the frequency one by one. So this is 1, becomes 2, becomes 4, and then it becomes 7. So this is called as cumulative frequency. Then for cumulative distribution function, it actually adds up the probability of the previous class, for example. Okay, for example, let's try to find the cumulative distribution function for the following probability distribution. Okay, we are given with the table of value of x and the probability of x. So we have 1 over 4, 1 over 2 and 1 over 4. Okay, so now let's change this table into cumulative distribution function table. Cumulative distribution table. Alright. Okay, we also have x over here, 0, 1 and 2. Okay, for the px, now it will be changed into fx. So for fx 0 means f0, it means the probability of x that is less or equal to 0. Then for the probability of f1, it is equal to probability of x less than or equal to 1. Okay, then for cumulative distribution function 2 is equal to the probability of x less than or equal to 2. Okay, to calculate this is by looking at the probability of x. Okay, so for probability of x less than equal to 0, right over here, fx less than equal to 0, we have 1 over 4. So f0 is equal to 1 over 4. Then for f1 is a probability that is less than or equal to 1. For less than equal to 1, it could be 0 and 1. So it be equal to 1 over 4 plus 1 over 2. So it becomes 3 over 4. Then for f2, it will be equal to probability of x less than or equal to 2. So that is 0, 1 and 2. So that comes 1 over 4 plus 1 over 2 plus 1 over 4, and that's become equal to 1. So just the same thing as we did for cumulative frequency. Okay, so now we rewrite this table since we have the value. So x 0, 1, 2 and the frequency fx, so it becomes 1 over 4, 3 over 4 and 1. We place this value inside the table. Okay, so this is the cumulative distribution table, and now let's write its cumulative distribution function. So since it is a function, so it must be an equation of fx. So sorry, it's a capital fx. Okay, like this. So equal to, if we start from 1 over 4. Okay, so 1 over 4 is the value that starts from 0 until x but less than 1. It covers from 0 until less than 1. So then next is 3 over 4. So 3 over 4 covers from 1 less than x less than 2. So it covers from the region from 1 until 2. Then 1, it covers from x that is bigger than or equal to 2. Okay, now we have the region starting from 0 until 1, 1 until 2 and x bigger than 2. We need to add one more thing, that is 0 right over here, that covers any value of x that is less than 0. So then we have complete our cumulative distribution function. So it must be covers from lower than 0 then and higher than the value of x, so that is x equal to bigger than or equal to 2. Alright, so to understand further about the inequalities right over here, let's form the cumulative distribution graph. Okay, this is cumulative distribution graph, that where the y-axis is the fx, then the x-axis is the x. Right, so we have the value of 0, 1 and 2 that will be placed on x-axis, 0, 1 and 2. Okay, so the value on y-axis, there is 1 over 4, 1 over 2, 3 over 4 and 1. Okay, for 0, where the x is 0, that covers any value that x is less than 0, the fx is 0. So fx, when x is less than 0, this area, the value is 0. So this is the value of 0, and it is until x is less than 0. So you make a hollow circle right over here. Okay, so then the next region, x is bigger than or equal to 0. So since it is bigger and equal to 0, so it must be a bold circle right over here until x is less than 1, a hollow circle with the value of y equal to 1 over 4, or x equal to 1 over 4, like this. Okay, so the next region is x is bigger or and equal than 1. X is bigger and equal than 1, where the fx is 3 over 4. So right over here is a pole because it's equal to 1 until less than 2. So a hollow circle for 2. And then the last one, x is bigger and equal to 2 for the value of fx equal to 1. A bold 1 and drag it bigger than 2. So this is the frequency cumulative distribution graph. So I hope that explains about the inequalities written in the cumulative distribution function right over there. Okay, so one more thing that we need to know from the probability of a less than x less than equal to b is actually equal to the probability of x less than equal to b minus probability of x less than or equal to a, and that is equal to f b minus f a. Okay, so this is a formula. Okay, so now let's apply this formula in our example. That is the probability of 0 less than x less than or equal to 1. Okay, let's say we are given with this question. We want to find the probability in between this region. So this form can be changed into probability of x less than or equal to 1 minus probability of x less than or equal to 0. Okay, so for probability of x less than or equal to 1, so we look at here, x is less than or equal to 1 is equal to the okay, for probability x less than or equal to 1 is actually equal to f1, and the probability x is less than or equal to 0 is equal to f0. So we can refer on our graph that we have already obtained the value of f1 and f0. So the value of f1 is right over here, that is 3 over 4. This is 3 over 4 minus f0 is right over here, that we have is 1 over 4. So our answer is 2 over 4 equal to 1 over 2. Okay, we can also try to prove this by calculate the probability of 0, x and 1. Probability of 0 less than x less than equal to 1. Okay, so for this one, okay, so this probability is actually equal to the probability of x equal to 1 only. Why do I say like that? Because you can refer back on the question. The question 1, the probability that x is bigger than 0 but less than or equal to 1. So it only includes this area. We cannot take the 0, 1 because x must be bigger than 0 and x also must be less and equal to 1. So that's why our answer is equal to 1 over 2, just like the same answer we have calculated by using the frequency cumulative distribution. Alright, so what do I want to summarize from here is that when the question given written as F2, so this actually means the probability of x less than or equal to 2. So it also means the probability of x equal to 2 plus probability of x equal to 1 plus probability of x equal to 0. So satu-satulah kat sini, each one of these you have to return back from 2 you go to 1 and then you go until 0. That is for F2. If the question said F1, that is probability of x less than or equal to 1. So x is less than or equal to 1. That means the probability of x equal to 1 and the probability of x equal to 0. That is why it is called as cumulative, because it adds up all of the previous data. F0 means probability of x less than or equal to 0. That is just equal to probability of x equal to 0, because we don't have any other value that is less than 0. Okay, so now let's look at two more things, the mode and the median. Okay, the mode and the median. So how to find the mode and median from given random variable. Okay, in order to determine the mode, we must find the value of p x equal to x, the highest value of probability x equal to x in the data. So that is the mode of our data. And the median, okay, the median for discrete for probability distribution is when the value of probability x is less than m, is bigger than 1 over 2, and probability of x bigger than m is bigger than 1 over 2. Okay, never mind. For median, we will look at it later, but we need to understand the meaning of 1 over 2 here. 1 over 2 means the half, the median. So when we reach the calculation of 1 over 2, so that means we have already obtained, we can already find the median. Alright, so let's try to find the median and mode from this question. Okay. Okay, so let's look at question A. So the mode, already said before, is where the probability of x equal to x is the highest. So let's focus on the table. We have to find which probability is the highest, that is 0.3. So then our mode is 8. Okay, right over here, 8. The value of x is our mode. Okay, then for median, we have to add up one by one. We will start with the smallest value of x. Smallest value of x here is 2. Then we will do 4. Then we up until 6 until we reach the probability of 0.5 or 1 over 2. Okay. For median, as I said, we start with So we write down probability of x less than or equal to 2. X less than or equal to 2 means probability of x equal to 2. So that is 0.2, not 0.5 yet. We have to go to the next stage until we reach 0.5. So the next number of x after 2 is 4. So x less than or equal to 4. So x less than or equal to 4, that is probability of x equal to 2 plus probability of x equal to 4. So that will be 0.2 plus 0.2 means 0.4. So not yet 0.5. Then we go next with the probability x less than 6. Probability of x less than or equal to 6. So means probability of x equal to 2 plus probability of x equal to 4. Okay, so 0.2 plus 0.2 plus 0.1, then we have 0.5. Alright, if we get until the number of exactly 0.5, okay, if the number is exactly 0.5 where the x is less than or equal to 6, so we need to add up 6 with the next value of x, that is 8, and then divide it by 2. So 6 plus the next higher value of 8, the value of x, 6 plus the next higher value of x, that is 8, and divide it by 2. So then we have our median equal to 7. We divide it by 2 if we obtain the value that is exactly 0.5 or 1 over 2. Okay. Now let's look at the second situation of question B. Okay, for question B, the mode is still the same. We have to observe the highest value of probability. So the highest one is 0.4. So probability of x equal to 0.4 is the highest. Then mode is 2. Okay, where x is equal to 2. Okay, try to find the median. Okay, the median, we start the lowest value of x. Probability of x less than or equal to 0 means probability x equal to 0, that is 0.1. So we do it until we reach 0.5 or higher. Okay, cannot be lower. So x less than or equal to 1. So this one is 0.1 plus 0.3 equal to 0.4. So not yet reach 0.5. So x less than or equal to 2. So this one will be 0.1 plus 0.3 plus 0.4. So this is equal to 0.8. Okay, so when we have reached a number that is bigger than 0.5, so we are done. Okay, when the number is bigger than 0.5, we can just take directly that class as the median. So our median is 2. So our median is 2 based on this number. If the number is exactly 0.5, then we need to add up 2 with the next number of 8, number of x, that is 3. So 2 plus 3 divided by 2. If uh, the median is exactly equal to 0.5. So if the median is higher than 0.5, so we can just take it directly as the value. Okay, now let's look at another example. A discrete random variable x has the following probability distribution function. Find A, the cumulative distribution function, and sketch its graph. Okay, so in order to form the cumulative distribution function, then what we need to do is we have to calculate every each of the cumulative distribution function. Okay, since we have x that is equal to 0, 1, 2, and 3. So that's mean we have to find the f0, f1, f2, and f3. Okay, so this is for question A. Start with f0. So f0 means the probability of x less than or equal to 0. So that is probability of x equal to 0 and equal to function where the x is 0. That is when x is 0, the value is 1 over 6. Okay, then we go to f1, means probability of x less than or equal to 1, means probability of x equal to 1 plus probability of x equal to 0. So x equal to 1 mean probability of f1 plus, sorry, not probability but function f1 plus function 0. That is f1 is 1 over 3 plus 1 over 6. So equal to 3 over 6 equal to 1 over 2. So the next one is f2. Probability of x less than or equal to 2 equal to probability x equal to 2 . Okay, and then f2 plus f1 plus f0, so equal to 1 over 2 from previous f1. Previous we have calculated from here, 1 over 2 plus 1 over 6, so we have 2 over 3. So that is only until f2. Then next one is for f3. So probability x less than or equal to 3. Okay. Alright, so our f3 means we take from the previous calculation, that is 2 over 3 plus f3, that is 1 over 3, so 3 over 3 equal to 1. So we have done our calculation for cumulative distribution. Now let's form the cumulative distribution function. Okay, by using this f0, f1, f2, and f3, the highlighted ones. F0, f1, f2, and f3. So our fx to represent the cumulative distribution function, a curly bracket, where we have f0 1 over 6. So that is 1 over 6 for the region that is 0, x less than 1, because we have to start with 0 right over here where x is less than 0. So then we have to move up where x is bigger or equal to 0 until 1. So then after 1 over 6 we have 1 over 2 for f1. So 1 over 2 covers from region 1 less than x until 2. Then for f2 we have 2 over 3 for the region 2 less than x less than 3. And finally we have 1 for f3. Sorry, for region that x is bigger than 3. Okay, so this is the cumulative frequency cumulative distribution function. And now let's form the cumulative distribution graph. So this is the fx, and this is for x. We have 0, 1, 2 and 3. Okay, for value less than 0 the fx is 0, a hollow circle right over there. And then for the value starting from 0 until 1, the value is 1 over 6. Okay, right here. And then the value starts from 1 until 2, it is 1 over 2. So 1 over 2 is 3 over 6. Okay, then 2 over 3, and then any value bigger than 3. Alright. Okay, so this is the graph. Okay, now let's continue the cumulative distribution function. And for question B, probability of x is less than or equal to 2. Okay, for question B, probability x less than or equal to 2, this is actually the same value as f2. So we already did the calculation. f2 is 4 over 6, or just equal to 2 over 3. So fc, probability x is less than 1. So for probability x is less than 1 is actually equal to probability of x is less or equal to 0. That is 1 over 6. Then for question D, probability 0 less than x less than or equal to 3. Okay, so for this one we already did the formula before. This is actually just equal to the, so it actually equal to probability of x less than or equal to 3 minus probability of x less than or equal to 0, and also equal to f3 minus f0. So So that is 1 minus 1 over 6 equal to 5 over 6. Okay, then for E, for question E, where the probability of x bigger than 2. So probability of x bigger than 2 is actually the same as 1 minus probability of x less than or equal to 2. Okay, they want x bigger than 2, so we take 1 minus probability x is less than or equal to 2, so means we have the opposite of that. So 1 minus f2, so means 1 minus 2 over 3, and it becomes 1 over 3. Okay, for question F, probability of x less than negative 1. So since x right here is less than negative 1, so we didn't have any value of x less than negative 1, so this is just equal to 0. Okay, then for G, the probability x less than or equal to 0, you want to find the median, so we start with the lowest number of x. Lowest number of x, so that is 0, so 0 is equal to 1 over 6. So we go next where x now is less than or equal to 1, so this will be probability of x equal to 0 plus probability of x equal to 1, that is 1 over 6 plus 1 over 3, and equal to 1 over 2. So this is exactly 1 over 2. When we have exactly 1 over 2, what we need to do is we have to take this value of 1 plus the next x value, that is 2, then divide it by 2, so then we have 1.5. So our median is 1.5.